Hi, welcome to the SunCat Byte for the workflow for Program 2, the Mini Cooper. As you can see, I have created a project for it on Visual Studio. I've added my driver file, and I've put comments at the top of my file for my name, email address, the file name, and a short description. In addition, I'm going to start with my pound includes. What am I going to need? Well, almost always I'm going to need IOStream, so I'm going to add it because we're going to ask the user for input and display output to the user. This time I think we're also going to need string because we're going to use some string input. And I'm going to add using namespace standard. Okay, all set. By the way, I don't know if I told you all how to put numbers on your code. If you are interested in doing that, it's pretty straightforward. Let me show you. Click on Tools, Options. We're going to go to the text editor and then go to C, C++, and General. If you look over here on the right, there's a checkbox for line numbers. If you want them, check it. If you get sick of them, uncheck it. Okay, so now let's start our program with int main and open and close braces. All our code goes in between those braces. I'm going to look at the spec to see what it is it's telling me to do. Okay, the first thing to do, it says, is to, and I'm going to make these comments, these are things for you to do, print course header. And you recall what that is. It's your name, the program name, and what you're doing in the program, and any instructions or special information that you may want to include for your user. I'm going to make these to-do comments so that you can find them in the task list. Okay, then it's a good idea to create some variables and see what you already have. So what do we already know? We know that the Mini Cooper, this is not good code, so I have to put it in a comment, has 24 or 32.8 cubic feet of cargo space, and this is for the 2-door, and this one's for the 4-door. Okay? All right. Then we know that both can carry 1,800 pounds because they've been beefed up. Okay, so we need to get information from the user about the type of metal that you're going to use, whether it's gold or aluminum or copper or lead. And I think those are the, oh, you know what? I'm completely wrong. What are they? They are, okay, they are gold, silver, platinum, aluminum, and copper. So I guess no lead. Who wants a lead bar anyway? All right. So we've started our program, we've created some variables, and what will those variables look like? Well, let's see. How about we're going to need to know which type of Cooper it is, right? And what we're going to say is that 2 equals 2-door and 4 equals 4-door. Kind of straightforward. And we can say double type 2 cargo is going to be 24, and double type 4 cargo is going to be 32.8. Okay, so we have taken this information that we have here and we have put them into variables. We can immediately calculate the volume of a bar because they are all the same. They are 7 times 3 5/8 times 1 3/4. And that equals to what? Yeah, 44.4 cubic inches. So you can calculate that right away. It's going to be used no matter which bar type is chosen. Then you're going to set the densities of the metals in pounds per cubic inch. So, for instance, double aluminum, I'm going to go density aluminum is 0.098. Okay, so you're going to set those densities for copper, silver, platinum, and gold, as well as aluminum. Okay, and you may want to create a string answer having to do with your do-while loop. So let's open the do-while loop. Okay, and step 1 is find out what values you will use in your calculations. How do you find those out? By asking the user. So you're going to see out please enter, no, please select the model of Mini Cooper. And then I'm going to say 2 equals 2-door hardtop. Four equals 4-door hardtop. Put a little extra space in there. Oh, look. There we go. And then sometimes you can leave a space there and you can let the user input their answer. And now their answer, whether they choose 2 or 4, is going to be Cooper type. There you go. All right, then you're going to ask for metal type. The spec says to use the chemistry abbreviation. Okay, so you can tell them to write Al for aluminum, etc. All right, so you tell them what their choices are, and then the metal type, I didn't make a variable for it, so I will do that over here. That's going to be a string metal type. Whoops, no caps. There we go. Okay, because if they put in 2 letters, that's 2 characters. It can't be a character, it needs to be a string. Okay, so then you're going to CN metal type. Okay, and you'll know which metal they want to use. Then you're going to ask how many bars. Again, you're going to see out how many bars, and let's see, this could be int how many bars, and see out how many bars, and then see in how many bars. Okay, so and get answer from user. Now you have all the information you need. And it is time to think about how you're going to handle it. What you need to do is assign the density of the metal and the metal name depending on which one is chosen. So how are we going to do that? Well, we can use if-else statements. If metal type is aluminum, then we're going to say that density, and we haven't created a density variable either, so oh, there it is right there. Density is equal to density of aluminum, and the metal name is equal to aluminum. Yeah, what's it telling me? It says that I don't have this identifier. It's unidentified. How does it say it? Identifier is undefined. Okay. So what I need to do is go up here. We have metal type, but we also need metal name. So I'm just going to put a comma in here. Metal name. Now we're good. Then we're going to go else if, and we're going to continue. And you're going to check all of them. Okay, so you are setting these variables that you're going to use to calculate with depending on what the user chose. There's a good demo on how to do if-else ifs, and then you end up with an else. in Bo's SunCat Byte. Let's see what that one is. That one is Module 2. Here we go. SunCat Bytes for if-else statements. That's 2.3. That shows how to do those. Now, one of the interesting things is that the spec says we can also use a switch statement. Well, that's a little bit less straightforward, but I'm going to show you how to do it. Because you might want to try it. Here's the thing. We cannot, this is what a switch statement looks like. And I'm just going to comment these out so they won't get in my way. Switch. Now, I need to have a variable to switch on. And the variable has to be an integer type. So it can either be a counting number or it can be a char. Well, we're putting in strings over here. So you have a couple of choices. You can tell them to write, well, the spec says you have to write AL, okay? So you can also make it a menu that has numbers. So let's see what that would look like. Metal type is a string, so I'm going to comment that out up here just to show you how to do the switch. Okay, so ask the user to choose a metal type. So we could do it this way. Please select a metal type. Okay, so what we're going to do is give them what's called a menu. 1 is aluminum. Okay. Two, whoops. Please select by number. Okay, so let's try that again. So 2 will be Cu, copper. 3 will be silver. 4 will be gold, which is Au. And then five will be platinum, which is PT. And we're going to need int selection. And then over here we're going to have CN selection. So instead of writing AG, your user is going to pick 1 through 5. Now when you get down here, you can put selection in there and use it, because selection is an integer. So you're going to have case 1. What's case 1 going to be? It's going to be aluminum. And what are you going to write in case 1? You're going to say density equals density aluminum and metal name equals aluminum. So you see you're doing exactly, whoops, there. And then break. And there's case 2. So you're doing the same information. Here you do it with an if, else if, else if, else. Here you do it with switch statements and cases. You're welcome to do it either way. It's a little more trouble to do the switch statement because you have to move to integers, but either way works perfectly well. There isn't one that's right or one that's wrong. Okay, so when you have step 1 is finding out the values, and that's what we did. We found out all the values. Now we're going to go to step 2, and that is assign the values into the variables we are going to use for our calculations. Well, there we go. So the variables for calculation are density, we already did that. Metal name, we did that. That's not actually in the calculation. Now, we need cargo, cargo volume, bar weight, total bar weight. Okay? So we have some things to do. And do the calculations. I can never spell calculation. There we go. Okay, so what are we going to do with cargo? Double cargo, right, if Cooper type is equal to 2. Be sure you use the double equals when you are comparing, because otherwise you're setting it equal to 2 and you're not checking to see if it is 2. These are relational operators. Cargo equals type 2 cargo. Okay? Else cargo equals type 4 cargo. Now you don't have to check both 2 and 4. It's either 2 or 4. So if you check that it's 2 and if it's not 2, it must be 4. Don't do unnecessary checks if you don't have to. Okay, so how much does each number of bars weigh? Okay, we did this calculation in the test cases. So let's see how it's going to work here. Just about the same. Okay, so double bar weight is going to be, what's our variable for the, here it is, the volume of the bar, double bar volumes equal to, and you're going to do that calculation. Okay, so it's bar volume times density. Oh, ha! There we go. Couldn't comment that out because then it can't see it. All right, so that's how much each bar weighs, and double total bar weight is going to be equal to bar weight times how many bars? Okay, now we've done a lot of calculation. Now check to see if the total bar weight, this should be a capital B, is less than 1800. Report to the user. That was question 1, right? Or question 2. Okay. Then we need to calculate the total bar volume. So we can see if they'll fit into the cargo, right? So how do we do that? Total bar volume is equal to how many bars times, oops, that's a capital M. How many bars times bar volume. Now that's going to be a double, and we want to round up, don't we? If we round up, let's see, the volume of 1 bar is 44 cubic inches. So if all we do is round up, are we going to round up by 1 more bar? I don't think so. So I think what we may have to do is let's just do it. How do we round up? We go double total bar volume equals ceiling of total bar volume. Okay, so that works out. How can I have total bar volume on the right side and total bar volume on the left side? Because the right side is calculated first and then assigned into the left side. That can't be double. Redefining it. Okay. So I have that. And now to what? What am I comparing it to? Cargo. Because isn't cargo, where are we? I think cargo is type 2 cargo, and type 2 cargo, yeah. So cargo is how many cubic feet of cargo space there are. But first, change total bar volume to cubic feet, then compare. Finally, check to see how many bars you will need to weigh 1,800 pounds. Then check to see if the volume of these bars, let's see, that should be of these bars will fit into the car. Tell the user what happened. Ask the user if they want to go again. Oh, this is it right here. And get answer. So this is while is equal to yes. Remember to tell the user what the choices are for the answer, like Y or N, yes or no, something. You know, you need to tell them so they aren't just guessing. Okay, and then if they say no, say goodbye. Okay, that's it. Oh, one more thing. Return 0. Okay, there's your program. If you have any questions, be sure to email me or come to office hours and I'll be glad to answer them. Bye.